Before we proceed on the complex circuits, so last time we have discussed about the current across parallel resistance. So this time we are going to give a simple problem for power distribution in series circuits. So we have another exercise for this evening. Suppose we have a series circuit with a supply of 150 volts and 3 resistors, R1 330 ohms, R2 680 ohms, and R3 910 ohms. What is the power dissipated by R2 resistor? Calculate the total power in the circuit. Okay, so this is the circuit diagram of this problem. So we have 150 volts and we have a 3 resistors in series, and then we are asked here what is the power dissipated by R2 resistor. Okay, so this one, what is the power for R2 resistor? So solution for step 1, we need first to calculate the total resistance of this circuit. Okay, so since this is connected in series circuit, so we just add up the individual resistance. So 330 plus 680 plus 910, so the total resistance is 1920 ohms. Okay, so that is for step 1. Step 2, so for us to get the total power, since we are going to solve power in terms of current times resistance. Okay, so to calculate the power on R2 resistor, so we need first to calculate the total resistance. We have 1920, and we need first to solve the current of this circuit. So from Ohm's law, we have V equals to I times R, which is R is the total resistance. So just transpose and substitute the value. So we have for V we have 150 volts, and for total current we have 920 ohms. So the current is 78.1 milliamperes. Okay, so this is the total current of the circuit. And then to get the power on the R2 resistor, so we have this formula. Power in terms of current and resistance. Since we have already a total resistance of 1920 and a current of 78.1 milliamperes, so By this, with this, we can now compute the value of P2 here. Okay, so the formula is P equals to I squared R. So this is the current and this is the resistance for R2. So substitute the values and then we get a 4.151 watts for the resistor R2, for the power of resistor R2 here. Okay, then to calculate the total power of the circuit, we just add up also the individual power of these three resistors. So total power is equivalent to P1 plus P2 plus P3. So for total power in the circuit, so we just add the individual power of each resistors. So P1 plus P2 plus P3. So for P1 we have the current value of current is 0.07813 squared times this one, the resistance of R1 plus the total current squared times the resistance of R2 680 ohms plus total current I squared times the R3 resistance. So equals 2.014 plus 4.151 plus 5.555, total of 11.72 watts or approximately 12 watts. So this is the total power of the circuit. Okay.